We can simplify a bit before we find the derivative. We can rewrite by dividing each term by x to the third. So this is 11 for the first term, because x to the third divided by x to the third makes 1. 8x divided by x to the third, that makes 8x to the negative second because of the power subtract. And then 1 over x to the third, I'm going to write that as x to the negative third. And now an integral is like a derivative in that it's a linear operator. You can take the antiderivative of each term. The derivative of 11 is 11x. The antiderivative of 8x to the negative second is going to be negative 8x. Let's see, negative 8 over 3x to the negative third. And that's because when you take an antiderivative, oh, sorry, I have that wrong. I was right the first time. Negative 8x to the negative first. Because when you take an antiderivative, the power increases by 1. That's the anti of a derivative, right? Derivative of the power usually decreases. Now, with an antiderivative, the power increases. You've always got to check to make sure it would work out. Now, if I take a derivative, that's why I have a negative sign out here, because negative 8 times negative 1 makes positive 8. Then it gets reduced by 1. And then here, I'm going to need a fourth. And it's going to be negative 1/4 x to the negative fourth. Because the negative 4 comes down and multiplies, then the oh, no, I did it wrong again. Sorry. That's the antiderivative. Because the negative 2 comes down and multiplies to make positive 1, because of the coefficient we had before, and then the power gets reduced by 1 to turn it into x to the negative second. And then since there's no limits of integration, we need some constant c. Because if you were to take a derivative of this right now, it would turn back into this with some algebraic rewriting. If you just put a plus 1 on there, the derivative still would turn back into this up here.